The Masters in Computational Applied Mathematics at the University of Edinburgh covers a range of topics. So it covers things related with applied mathematics and computational mathematics, both from a theoretical point of view. So we spent a lot of time discussing about algorithms, but also for a more practical point of view, since the students are given the opportunity to practice their programming skills and apply what they learn from theory in practice.
So the program covers a wide range of areas in applied mathematics, and the core here is computational modeling, which combines programming with numerical methods. And these are then used in high-level modules in applied mathematics, like machine learning and mathematical modeling. This includes dynamical systems and stochastic modeling. Students also can choose to tap into other areas like statistics or optimization.
The main reason I would recommend this to prospective students is firstly the wide spectrum of courses you can choose from. So if you're more interested in working in the industry afterwards, you got some more data and programming related courses there. But if you're more interested in research, maybe more analytical mathematics, you also have that more theoretical course as well. And the academic stuff, they're quite helpful about guiding you through your journey, what to choose and so on. And one other thing is the background of your cohort. Some people come from economics, some people come from physics, and some from engineering. So this interchange of knowledge can lead to quite fruitful discussions with your peers and ultimately good experience for every one of you.
The program is led by one of the largest applied computational mathematics groups in the UK, and one of the very nice features of the program is that the teaching that takes place on the program is mostly research-led. The modules that we teach on the course, a lot of them are directly related with our research that we're doing now and not research that has been happening a while ago.
The course offers key skills in computational and applied mathematics, which are important for modern careers in areas like finance, data science, or engineering. Additionally, our students often pursue PhDs in a variety of areas as well, like mathematical biology, fluid mechanics, or biomedical informatics.
Some of the main skills that I took away from the course are research skills, so that was definitely quite helpful. And the number of workshops, these hands-on experiences that can help you improve your mathematical skills as well.
The skills that students will learn in CAM is first and foremost mathematical thinking, so it's a structured approach to problem solving. Second is Python programming, which is very much sought now by the employers. Students also do a presentation during their research skills project, so they will have certain presentation skills as well as academic writing skills from writing reports.
In addition, I think one of the great features of the program is the dissertation that happens at the end, where the students get an opportunity to work with one of the members of staff from the Applied Computational Mathematics group, one-to-one for 3 months, working in an exciting and interesting mathematical problem. But in addition, for students that they are more application-driven, they also get the opportunity to do a project with one of our industrial partners, and again, gain a better understanding of how mathematics are used in industry.
So currently, my dissertation project is on modeling cancer evolution and how external damage processes can affect the mutations we see on the DNA strands. What we are doing is we are analytically and also numerically modeling the DNA damage process and then getting outputs on some very interesting measures and using data we want to infer. For instance, how well does the DNA repair process work, or how much of external damage was done to this strand.
My piece of advice to prospective students is don't be afraid to explore new areas of applied mathematics. You never know where you will find your passion. Second is don't be afraid to talk to your professors. If you like the subject, then it makes sense to explore it deeper, maybe through your dissertation. And finally, enjoy this process. It might be the last time that you do your full-time study.